Hi, I'm Tom Hall with FMS, and I'm going to introduce you to our new technology here, the EZPrep Plus. Um, it's an automated system. We've kind of taken some of the best features of our Power Prep system and our Easy Prep system, which is a semi-automated system, and we've combined those two to make a very simple system to use that's very fast and low cost. You can see here, you're going to be able to do 1 to 6 samples at a time. That's all controllable through this module here. We have 6 pumps, so these are your individual pumps. You can have up to 4 solvents with this system. And you have all of your, this is the stage 1 here. Everything's going to go to waste here, and then in the back, that's where you're going to do your fraction. So that's the only time you're really going to handle it. You got to load the samples, of course. So we'll talk about that as he goes through the presentation. So there's no cleaning from here to this connection here that's above the where your sample is. We will talk about those samples. He's going to go through this in more detail, but I just wanted to cover this a little bit with you. These are olive oil extracts for this demonstration, but I want to remind everybody that we typically, if it's a solid, like for food or soil or environmental, we have, this is a cell to our PLE, pressurized liquid extraction system. We extract that, then we're going to load it into these vials over here. And then, of course, these are all collected into concentration vessels, which are going to go into the super vat here at the end. The whole process here, this is a high capacity column set. We're just going to talk a little bit more about the columns, but all of our columns are tested. They come in pre-packed containers, and this is to eliminate any possibility of contamination, etc. So you just open them when they come to your lab and when you're ready to use them. Ruud's going to explain the snap column technology, which is really easy to use. And with that, I'm going to hand it over to Ruud. Thanks, Ruud.
Yeah, so this is the
Get to move into the picture.
this is the you can see this male and female. This is the acid silica. This is the carbon. This is the 6 gram aluminum.
You can pull those off and come closer to the camera. Yeah, yep, that's good.
So you see the connections here. And, for the purpose of this webinar, we are going to do a little bit different than usual order of the columns. So usually it's a silica, alumina, and carbon, but here we have switched the carbon and the 6 gram alumina around. So outside of North America, we have been selling a lot of the column techniques to have no dichloromethane involved in the cleanup. We changed the carbon a little bit. It's strictly hexane and toluene. It's only 2 solvents. No more DCM. In North America, people use it a lot. So it's not as important there. But since this is a very international webinar today, we're just going to demonstrate the hexane and toluene method. The 2 bottles here are on the left. Tom already talked about the extraction. Today we have olive oil. For the olive oil, you don't need any extraction. You just can use it as such. And it's just for this demo purpose that we want to show the oxidation pattern of the columns. This is the multi-pump. Tom already mentioned you can run 6 samples at a time. You have 6 pump heads here. They're color-coded like red and black, etc. We have the on-off switch. We have a nitrogen feature here, which we use typically at a low setting, about 5 psi pounds per square inch, or about 1/20th, I guess, of an atmosphere. to blow the hexane during the first step of the process down onto the column after the loading of the hexane is done. Um, you can have up to 6 solvents. This unit here has 4, but we have them also up to 6 different solvents. And here are the solvent lines going to the top of the setup here. So all this is really a pump. I mean, that's all it is. It doesn't do anything else. We have a memory card here where you can store methods. Here we have the layout. You can choose up to 6 solvents here. There's a calibration function also. Here you set the flow and the volume. Those are the real 2 most important parts. You can select each of the 6 pumps. So if you would just want to run a few samples, not 6, you can do that. Here you have real-time pressure readout, which will be activated once you start the flow through the columns. Here we have the nitrogen key here that you can use to blow out the solvents or the sample reservoirs here. We call them sample reservoirs or syringe vials, they're also called. And there is also a configuration button. Like I already said, a calibration function, but those are typically not very often used. The calibration of the pumps is very stable throughout time. You can go many months and many samples without having to calibrate the samples. There's a stop and hold function. The hold function is actually important. It has a built-in alarm for overpressurization, which you can reset here on the right. And if you hold the step, then it will just stop at the already dispensed volume. And if you resume it, then it will just go on. So you don't have to do any calculations in your head by already how many mils you already dispensed, and it's reset to 0. If you press hold, it won't be reset, and it will just resume the step that you're working on.
We're just show the reset button again. For the
Yeah, I
pressure.
can reset it. See on
Yeah.
the right. It's
I
a little
didn't-
black button.
Yeah, I had
It says reset on
Yep.
top of it.
I had it zoomed way in. So.
Yeah, I think those are all the different parts. Yeah, so each pump head also has the corresponding part for the sample line or the solvent line on the right here. So red, black, blue, white, green, and yellow. And I think that's about it as far as multi-pump is concerned. Then here we have the setup. Here we have the columns, silica, high capacity, carbon, and alumina. This is the waste here, the waste manifold with a organic waste pump, organic waste bottle that you can see, underneath this lab bench. Here we have the 6 samples, so we use the sample reservoirs or syringe vials that will actually be loaded onto the column once we start the hexane step. And these are stopcocks that will open as soon as we start the procedure. There's caps on top here that you can twist 90 degrees with an O-ring on the inside to give a good seal. And these are the color-coded connections of the solvent lines with each of the 6 samples. On the other side, you'll see that later, you can twist this around 180 degrees. There's also a little button here that you can tighten so that it doesn't rotate around inadvertently. So this is the side where everything goes to waste. On the other side, we have a glass manifold or a fish tank, as we call it, with 12 collection tubes in there. You might be able to see it through the different columns at the back.
Okay, let me just show the waste bottle. So down below we have the waste that brown 4-liter bottle is the waste, and we have it vented up to this snorkel up above Rude. Okay, Rude. Good.
So we'll see that once we do phase 2 or stage 2 of this cleanup, where you will be collecting the alumina and the carbon from effluent. Okay, so I'm going to. I've set this for 160 milliliters.
You gotta open up.
Of hexane and 10 milliliter flow. Yeah, I'm going to start the heater right now, and I'm going to open up the process.
Blow through.
Yeah.
Okay.
How much should I
Rude.
Oh, it starts. What should I?
Got it? Yep. Rude.
As you can see, the oxidation is starting here now. We've gone through about 16 mils of the hexane right now.
Okay, so this is kind of the boring part. It's just loading the samples, and they all have different levels of fat, but they're at least 1 gram of lipid and fat, right, Rich?
Yeah.
So as you can see, they're all oxidizing very nicely on the columns, and this takes a while. But this also Rude on um, the instrument itself. There's a spot that you can actually see the elapsed time. Is that correct?
Yeah. Well,
Yeah,
the
so-
dispense volume.
Yeah, dispense volume.
And these are the pressures
Just gonna
here.
move-
So you see the pressures. It's
Yeah. So
the pressures look fine. The alarm is set, I think, for something like maybe 25 mils or something. But usually you don't. If there's any problem with pressurization, it's usually because of the carbon, because the carbon has such high density. But
let's see if I can see the.
it's usually very rare to have any problem with the pressurization. I mean, I haven't even seen a double digit pressure yet, but even over 10, so it's always fine.
So yeah, I'm not sure that you can actually read the exact numbers. My screen is small. They have a full screen, so they may be able to. I'm sure they'll be able to see it.
Yeah,
Let me just. And where are we at now, Rude? How many?
45 mils.
So okay. Yeah, so there's no we did no conditioning. We just loaded the sample direct to the column for this. This is dioxin and PCBs, right, Rude?
Yeah.
So that's
So if you do PBDEs, it's going to be in the dioxin in the PCB fraction. All PBDEs and PCBs will be they'll be in that fraction. Since we're using carbon, what actually is going to happen, the coplanary PCBs are going to be in with the dioxin fraction on the carbon here. So 77, 81, 126, 169. And all the other, the mono and the earth PCBs are going to be on the alumina, and all PBDs are going to be on the alumina. And so that's easy. You just a lot of. I mean, not everybody does PBDEs, and also they're harder to measure. And you like a shortfall and everything. It's just not that easy to measure, and they're fine mass. But if you want to measure PBDEs, then you don't need to do anything separate. You just have to analyze them in a separate run. So now we are at 60 mils, so it's about 100 mils to go. Usually the oxidation pattern is already established here. You can see that, and it's going to be, just staying at where it is right now. So it's about halfway down the pole, the high capacity.
right, Rude. So at this time, we have time to talk about the
evaporator.
why don't we talk about the super evaporator?
Yeah.
This is plenty of time, and we can just go back to that automatically running there. But okay,
Yeah. So
hang on, let me
I think
just adjust here.
yeah. So this is the super ev. So it's you can blow down all 12 samples. We're collecting 6 dioxin, 6 PCB fractions, C and PBD fractions. So you can all blow them out at the same time. This is a dry metal heating block, not a water bed. That's different from a lot of other evaporators that have a water bed design. So you have 12 openings here. There's a heating core inside, and just blowing nitrogen down each of these 12 tips here. This is the what we're using for collection. This is put it in 12 open. There's a thermocouple here that controls the heat, and the gas line is going. The difference is here. Nitrogen gas. So those things you can see it's labeled here where the 12 tools are.
Hang on, let me.
Oh yeah.
Show that. That's
So we have the direct to viral connection here. You see this is threaded. You put we have a little aluminum ring here that is threaded on both sides, so you can test your GC vial at the bottom. And what that does is you don't have to do manual sample transfer. I mean, once this is done with the closed bottom, you have to transfer it manually with a pipette, glass pipette, typically positive best pipettes into the GC vial, but you don't have to do it. It's closed down the bottom. Yeah. Okay, here we have the alarm also here, just like on the EZPrep Plus. There's an infrared beam in the bottom of each of these 12 openings, and depending on the tapering end of the tube, it either stops at half a mil or 1 mil end from final volume, and the alarm bell, so we can pick it up. This is the pressure gauge here. This is the regulator, and set the amount of flow you want. So this is the top of the screen for regulation. It comes with pre-programmed temperatures. For instance, let's say that I choose 50 degrees to blow down my samples. Then you have a heating up step and a sensor step at constant temperature. In this case, it would heat up first to 43 degrees. And then after that, it goes to step for 3 minutes here. After that, it goes to step 2 where it heats to 50 degrees and stays there. And then once each sample is down to the final volume, the alarm for that particular position will sound. You can also see here the elapsed time, the temperature. And you can also run the system in manual mode. Auto mode means you have these pre-programmed lines. If you do it manually, then you can regulate each of the positions individually. However, it will operate all at one temperature, and you can just pull it out. So manual mode you can sometimes use if you have a say you have a sample because it uses the infrared beam. If your sample has some like a different color or it has some other material in it, but which the infrared beam gets confused by, then you can run it in a manual mode and then you can just blow it down as low as you want yourself. So it's basically just human control at that point versus the control of the evaporator. There's also a hold button here, offset, which runs it's the whole program, so all 2 lines. If you do single, it will just run this line by itself. There's a stop. You can also plot the. There's nothing to see here now because we're not doing anything with it, but you can record. There is an SD disk at the back of the system. Also, the nitrogen hookup is at the back, and there is a about 2-inch wide exhaust that you can hook up to a hose. So that, and then, so you don't necessarily need to use it in a fuel hook. You can actually use it in any kind of.
Yeah, most labs do that. They hook up that exhaust hose and run it outside of the.
But you can store these plugs for easy evaporation. Your SD disk, if you want to do that. Some labs do that for lab accreditation purposes, etc. So that's sort of the idea here. Then if we go back to the top of the screen, there's an editor function where you can put your own programs. There's copy and delete and edit and save functions. Most of these programs are very short. It's just leading up and then the first step is heat up. Second step is constant temperature evaporation till the sensor tells you that the system is done. So you can copy and delete and have it saved here. If I go to exits, there's also a calibration function for the thermocouples where you can use different ice water in boiling water or whatever. It doesn't even have to be boiling. I mean, anything, say 10 degrees centigrade and 80 degrees centigrade or something like that, that's perfectly sufficient. You shouldn't have to do that much though. It comes calibrated as we send it to you. And then, yeah, shouldn't really be much maintenance that way necessary. Yeah, let's see, I think that's about it. Yeah, plotting can start with this there's a configuration that most people don't use. So that is about it as far as the evaporation is concerned. You're almost done with the and same. So we'll go back to that.
Okay, so
All right.
back the, let's see, I'm gonna move this camera back a bit, so that's finished, right?
Yeah. So the next step is we're going to push the nitrogen.
Okay, let me, get it on to the,
Yeah, just get it onto the columns.
yeah, hang on. No, I want to show the
Yeah, so
next step here, so hang on. Hang on. Let me.
I'm going to turn up now the nitrogen here to about 5 psi. That should be enough, and then I'm going to start at nitrogen here. And then you will see the solvent level in the syringe routes go down, and the rest of the hexane will be pushed onto the column of sets of waste. A little bit, about 4 psi. It should be plenty. You don't want to overdo it.
Yeah, let me just,
So this will take a few minutes. You can see the oxidation lines are very nice, very even. About all of them halfway through the acidic silica column.
Ruth, speak up to people who speak very soft. Yes, speak louder. I told you.
I'll close the stop roll now. So,
Yeah, wait till the nitrogen is done.
yeah,
I don't do that. Don't get under pressure. We shut it off from the actual position. Position.
these are done. Okay, so we're done with two. Turn off the nitrogen. Dispatch 0.
There's actually other ways. Can't you just turn off the position up there
Oh, the
to shut it off
the
without
pump
even
position.
using the
Yeah,
stopcock? You don't even need to do that.
yeah, you probably don't. Yeah.
Okay, all right, I just wanted to make that. The little green buttons up above, push your finger up there so you can show them the 6 positions. No,
Yeah,
on the software.
yeah, yeah. You
Yeah,
need the
right
button.
here.
Yeah.
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 Okay, all right, what's happening now?
All right, so I'm going to remove the solar blinds from the range files. Remove the range file. And I'll remove the column. So the heading has brought the options onto the carbon column and also the coplanar PCBs and the other mono-derivative PCBs and PVDs are going to be all on the alumina column. I'm now going to remove the carbon column
Speak up, Rick.
and I'm going to put it on the other side. And then we are going to elute all these columns, both the carbon column and the alumina column, in the reverse direction. You can see that I'm turning it upside down and putting them in on the stage 2 manifolds in the adapters there. And then you're going to elute these with 40 mils of toy bead. I'm now going to turn around the disc so that we can hook up the solvent lines.
The all of those column clips and the lines, that holder for the lines and everything, that all moves up and down for each of these procedures. Okay.
Giving them a twist with a lower fittings.
Get everything in there, and then
Yeah.
I'll try to see if I can.
Okay, so I'm going to switch to solvent 2, which is toluene. And because this is carbon, I'm going to lower the flow to 5 to just prevent overpressurization. And I am going to change the volume to 40. And then all the pumps are selected, and then we can start.
Your holder won't be crooked when you get one of these. Where did you see how you knock the?
No, I didn't change anything, but
Yeah.
so
So those are
you
usually
can see the toluene dripping into the collection tube. You probably can see that from the.
you can see it dripping.
So the advantage of the method is that you only have 2 solvents, and obviously if you are not using dichloromethane, that saves you time in this procedure. If you want to, there are other methods available. Tom already said you can do extract total and extractable petroleum hydrocarbons with a 6-gram neutral silica column. It's a very simple procedure. It's just one column.
Yeah, fluorosil cleanup for
OCP,
pesticide.
yeah, fluorosil.
Yeah.
And you can do also total separation of dioxin and PCBs. But then you do need DCM, then 10% DCM in hexane and DCM. And that involves 4 solvents, so that's like a somewhat longer procedure. And there is also, if you want to, a way commercial environmental laboratories in North America like to do this, where you can collect all 209 PCBs, which can involve collecting all the effluents, including the hexane. But there's also newer developments where you can just only collect part of the hexane and then collect the 10% DCM and hexane, and that will give you all the 209 PCBs in one fridge.
How many mils we got, Rick?
22 mils. So this takes 8 minutes because we're doing it at 5 flow 5 mils a minute because of the the back pressure that the carbon gives the system. You can try to do it at 10 too, but sometimes you'll get leakage or overpressurization.
People can ask questions through the chat when we have these breaks in the action here, where it's just pumping solvent. Some of this could be quite boring, but that's good, I guess. Fully automated, as you can see. You're also not restricted to this fish tank. The fish tank is just if you have an EZPrep 123 today, you can easily update your EZPrep 123 to an automated EZPrep Plus. We just changed the setup in the back. These we just send basically these racks and then something to hold the holder for the solvent lines. But if you want to use, or you need to use, larger evaporation tubes, etc., those can be definitely used. The fish tank's not really doing anything except for holding the sample in place with those connectors on the top, the lures. Okay. Good question. It says, we have a question. It says, you mean the new columns don't need to wash? It can be used direct, but the columns don't need to be conditioned. We found that technically for dioxin, the PCBs, you just load the sample directly, right, Rude?
Yeah.
Yeah, there's
not much
difference. You guys can test it and validate
in recoveries or cleanliness. Yeah, so there isn't really much point.
We're not going to tell you exactly what that you should do that or not, but you can do that. We've done lots and lots of testing where it's not necessary to do that.
So we're done with the carbon?
Now Rude's going to put the aluminum.
Right. Put the aluminum on the other side here. I can show this. The aluminum was connected to the waste manifold here of stage one with a mill-to-mill. That's one thing we haven't shown. There's a mill-to-mill little
Yep, you got to hold it down lower.
connection here.
Zoomed in. Yep.
And so we use those. I'll have to remove these now from the aluminum columns and turn them upside down and put them in the stage two manifold with the collection tube.
Can we just confirm that what high capacity column, silica column we're using? We're using the high capacity column for 2.5 grams of lipid or fat.
Yeah, and it says like 29 grams of acidic silica. And the last one So it's back here. Our next. The forward lines. The top of the yeah.
Make sure you speak that through.
And then we're going to do another 40 mils. Toluene through these columns, collecting the monomer of the PCBs and the PVDs. And that will be, yeah. Okay, so the alumina, I can just go back to going 10 mils per minute for the flow. 40 mils is already done. Solvent is already selected. It's going to be toluene, also 40 mils. I'm going to start the dilution.
Yeah, that's good.
Oh, and these are two others in the UTC. You can see the dripping. They're already on there, right? They're on there, okay. There you go. Yeah, so you can see the dripping. So this is the fastest 4 minutes, and then we're done. Yeah, so the multi-pump is very nice. It's very practical. It's easy to use, and at the end of the, if you put it away, what we found out is the best way to do it is go back to hexane as a solvent. So just once you're done with your cleanup, pump like 5 mils of or 10 mils of hexane through the lines here, and then blow it out with nitrogen, and then the lines are empty, and the system with the pump heads here, the solvent is drawn, so you put it away overnight or whatever for one more time, then it's one way to do that.
That says that we backwashing the alumina. Yes, the alumina is turned upside down, right, Rude?
Yeah, just like with the
And,
carbon, yeah.
Pushed back, pump in reverse, just like the carbon.
All right, so this is done. That concludes the procedure. Cleanup of the dioxins and PCBs and
Need to speak
PVDs.
up.
So again, all the dioxins are going to be in the carbon fraction with the proplanary PCBs, and all the monodiethyl PCBs and PVDs are going to be in the alumina fraction that we just collected here. And so you have 12 tubes here that can go into the SuperVap 12 evaporator.
Okay, so you can show that one. I ran out. State of the. You can see the.
Oh, are you want to turn the camera to the evaporator? You can see that the levels are very nice, very even for both the carbon and the aluminum.
Yep. Hang on. Yep. See that? They're very, very even with each other. So the volumes are very accurate and consistent. If that were a problem, you just recalibrate it, but it doesn't require recalibration often.
Right. Okay, so I'll put these into the.
So as you notice in this demonstration, this is like a high capacity type of, if this was a, half a gram or something like that, it would be even faster. But we've actually done, your traditional dioxin PCB fractionation cleanup in probably about 40 minutes. I mean, there's been a lot of talk, we're moving slowly because of this is a live demonstration, but you can see, tremendous speed. So really helping the laboratory get huge gains in throughput. So you can imagine if you just have these, so you set these off, you stop blowing those down. It's very simple to just, at this point, if you have an extra set of, fittings and stopcocks, which we recommend, so you can clean during the second run, but now you're just going to start and load up the next run. This system, as you see it right now, sitting there, requires no cleaning. The actual EZPrep Plus portion of it itself. You will have areas where you put the columns on for fractionation. Those are just the stage 2 lure fittings. So you have an extra set of those, so an additional 12, another 12 stopcocks, and another male to male. And you're ready to go. Pretty much well, and of course some syringe
vials.
Syringe vials.
But a lot of people throw them away. The barrels themselves.
So very little cleaning, but basically you have plenty of time to do the cleaning portion once you get the second set run. So you're looking at 6 samples easily per hour. So that's a huge increase in what you're seeing, and it's really a fraction of the price of any fully automated system that's out there, including ours. Which these have become very, very popular recently since we just come out with them. So we're the actual chat is open. So if you have any questions, please feel free to ask them, and we'll answer them. It says the collection finished. Yes, we collected. We washed, reversed the carbon for the first set of 6. That was already done before the aluminum.
Right.
So that was already done in the demonstration. In case for those of you who missed it. So yeah, everything's done. Okay, well we have no other questions. I hope everybody enjoyed that, and thank you again for. I know there's some. I see some U.S. people in the that participated. Hello, Dawn. Hope everything's good. Nice to see that you're there. It's early in the morning for you. Yeah, so we have some U.S. people where it's early today, and we're glad to do this for the folks internationally so that they were able to attend something like this at a reasonable hour and during their time. So with that, I'm going to, and this will send you the recording of this. Hopefully get it to you for tomorrow. Thanks again and have a good day.